Okay, so I did not press record, and I'm going to do this again. Figure S, the small arrow was dilated, which means to grow or shrink, with the origin in the center, to figure T, the large arrow. So we know we're going from the first S, is the first one, or the original arrow, to figure T, which is now the larger arrow, the second, or the new figure. Like I wrote here, we're going from S to T. And just by looking at it, it went from a small arrow to a larger arrow, therefore it means it grew, or it grows. And when an object grows, it grows by a whole number. And I'm just going to give my X and Y for point S. I'm just using this point. You can really use any point. It doesn't matter which one. I'll show you on this video to use another one. So I'm going to go and let's use this point here. So originally this X is at 2, the Y is at -8. So we have 2, -8, and that's for our S. And then our T point goes down to here. Oh, that's not very good. I didn't do a good one. But that would be 2.5 to -10. T, 2.5 to -10. Alright? I'm going to be honest. If I were doing this, I wouldn't want to deal with the decimal. So I'm just going to look at the Y values. It doesn't matter. You use either one. X, X, or Y and Y. So I'm going to use X, the Y's, because they're whole numbers. I like whole numbers. They make me feel better. So I want to go. It's going to grow. So therefore I need to find out what is that scale factor, or what does it grow by. So I'm going to do -10 divided by -8. And with our nifty calculator, -10 divided by -8 equals to positive 1.25. That is my scale factor. Sorry about that. That is my scale factor. Therefore, now I can write my rule. As you see, it did the exact same thing, just using 2 different points, still giving me the same scale factor. Boom, boom. Here's my rule. All we need to do, X, Y is where it originally starts, then becomes 1.25x, because I'm going to multiply 1.25 to every X value to get the new one, and then 1.25y to get every new Y value. Alright, question 4. I really don't like this question. Let's just skip it. It's too theoretical. I'll go to this one. Sorry. Number 5. Parallelogram ABCD was translated. Translated means we slide the object 4 units. I'm going to write the number 4 here to remind it units. And I'm going to put my arrow for down. 4 units down. And 4 right there. Units to the left. Left means this direction. Which rule describes the translation that was applied to the parallelogram ABCD to create the new parallelogram A prime, B prime, C prime, D prime. So we know the rule starts at X, Y is the beginning, the starting point, which then becomes Y went 4 units down and 4 to the left. So X is my first, and that means X goes from left to right, so I go 4 units to the left. Left is going in the negative direction, therefore telling me it's X minus 4. That's my X rule. Now my Y rule. It says it went 4 units down. Down is a negative, Y minus 4. There's our rule. X, Y translated to become X minus 4, Y minus 4. Guys, if you have any questions, just shoot it down. Shoot me an email. It's still the same, malvinmadmath@gmail.com. Alright, this is definitely a star-related question. The circle with the center O is graphed on the coordinate grid and then translated to a new circle with the new center. What rule describes this transformation? Alright, so what it wants to know is how many units did it slide, because it's talking about a translation. We want to know how many units does it slide to go from here to here. Well, we definitely know it goes up 1 unit, and that's between the two, so it goes up 1.5. Up 1 1/2, or 1.5, or we could use our improper fraction of 3/2. Many different variations. So we go up and then over we go over 1, 1.5. Then we went to the right, 1 and 1/2, or same 1.5 or 3/2. Okay, that's all we need. We need to know how many units and in what direction, so we can write our rule. Our rule, I'm going to do it from here, goes from xy to then become x and up means plus 1.5, comma, y to the right means plus 1.5. Boom. We got our rule. We got our rule. Okay. Next one. Y'all lucky, I like y'all. Circle I, or circle 1 was dilated to the origin as the center of the dilation to create circle 2. Which rule best represents the dilation applied to circle 1 to create circle 2? Guys, I'm going to tell y'all right now. I've seen lots of these test release questions. They love circles because kids hate them. Don't let them overtake you. Okay? So now this is our original and this is our new. So we look. Circle 1 is here. Circle 2 is here. So we went from 1 to 2. It became smaller. Therefore, our scale factor is going to be a fraction or decimal less than 1. Decimal then less than 1. So now we want to find a point. I'm always going to say use something that lies on the axis and that lies specifically. So I'm going to just zoom in for you guys to see this. It should focus there. So this one here is at 0, 8. 0, 8. And this one here is at 0, 10. 0, 10. Boom. Now I got that. So now I want to find out what is that scale factor. Same thing. Well, we can't find the differences between our y's because they're both zeros. So we just want to find out what is the scale factor to go from 8. This is my old, excuse me, not my old, my new divided by my old 10. So we just want to know what is the scale factor of 8 divided by 10, and we can keep it as a fraction, simplified, divide by 2, which is 4/5, or we could turn it into a decimal as 0.8 or 8/10. Now to write our rule, we just go from x, y to become, and I'll use a decimal this time. I could do 4/5 x, so you could say 4/5 x, comma 4/5 y, or you put up here, I don't have room down here, or 0.8 x, comma 0.8 y. Both would be true. Fractions and decimals are just different forms of writing a part of a whole. 8. Let's see. The coordinates of the vertices of pentagon are given. The pentagon is reflected. Reflected means flipped across the y-axis. Remember, when it tells you the axis, sorry, you couldn't see that. When it tells you the axis, that means that value or that symbol is going to stay the same. Create pentagon RSQ. Which rule creates this transformation? So all that means is every y value is staying the same. So the rule is going to be x, comma y becomes y stays the same. Therefore, it's going to be negative x, comma y. Y stays the same. And we write negative x, meaning we're changing the symbols of the x. If originally it's positive, it becomes negative. If originally it was negative, it then becomes positive. Number 9. Trapezoid PQRS is dilated. Again, dilation means when it grows or shrinks. With the origin at the center of the dilation, create the new trapezoid. Which rule best represents the dilation? Okay, so we're going to say PQRS. That's the big one. And then it goes into a small one. So again, when it goes from big to small, our scale factor is going to be less than 1 whole, meaning a fraction or decimal. Alright, this is not very alright, so then find a point that lies on a corner or an intersection. So like here, this one lies on an intersection, but if you look over here, I'm going to zoom in for you guys. Here it doesn't. So I want to find 2. What about S? S is here now. We're not really left with any friendly, so we're just going to have to just like deal with it and do it. So I'm going to go to R. My husband's name's Robert. So X here is 5 and 2. So R prime is at 5, comma 2. Oh, excuse me, negative 2. Of course, if I was a class, somebody would correct me. And then R is at, so we'll say 7.5 and negative 3. 7.5 and negative 3. Does it matter which one I use to determine the scale factor? No, it does not matter. Pick one. Alright? These are nice whole numbers. I'm staying with the whole numbers. Those are guaranteed to be true. So I want my scale factor to be a fraction. So I'm going to have my new divided by my old. New is negative 2. Old is negative 3. I'm going to just simplify. Negative 2 divided by negative 3 becomes my scale factor is 2/3. Because negative 2 divided by negative 3, used your calculator, you would get 2/3 as the finalized answer. Some crazy decimal, 0.6666 forever. But let's just keep it simple as a fraction. Do not be afraid of fractions. Do not, do not, do not. So therefore, we want to create our rule. We have x comma y. Then becomes scale factor goes in front of our variable 2/3 x comma 2/3 y. Boom. There's our rule. 10. Parallelogram. Baby CD is graphed on the coordinate grid and was rotated. That's our turn. So now we have to remember our turning rules. To form parallelogram. Jeez. A prime, B prime, C prime, D prime. Which rule best describes the transformation that was used to form the parallelogram? So we're going to look and we're going to say, well, just by looking at it, it goes from here to here. That's one quadrant. Therefore, it is only 90 degrees in either a clockwise. We have to determine if it's 90 degrees clockwise or counterclockwise. This is clockwise. This is CCW counterclockwise. Alright, so it goes from here to here. That's going against the clock. So it's going to be a 90 degrees counterclockwise. So we know our rule, our rule always begins with x comma y. To then become, now we're going to have an x. So when it gets turned 90 degrees, that means the x and the y's change places. So it's not x. I messed up there. It's y comma x. The thing is, you have to determine which symbol or which sign am I changing for what letter, x or y. So if I went from here to here, and then I go up to here, my x values stay negative. It's my y values that change. So here, even though it just, what I want you to look at is that the y values change. Yes, granted, originally it was a negative y from its original picture, then becomes into a positive y. But they don't want it to be that precise. They just want a very general or simple rule that can be applied. And that's why we're going to say, so the symbols change, the letters change. So now our y's become our first value, and our x becomes our second values, but the symbol changes. It originally was negative, becomes a positive. So we're just going to put a negative sign. Does not mean the values be turned negative. It just means they change from negative to positives. How many more we got? Good Lord. Let me go through this. Here we have a translation, and we just want a rule that describes the translation that is applied. Here's my old, and this is my new. So I need to see how many units. Does it go up or down for my x, and my y up or down? So x goes up. Up means plus, goes up 1, 2, 3, 4. And it goes across on my y-axis 1, 2, 3, 4. And to the right means plus. So my rule goes from x, y to become x plus 4, y plus 4. Boom. We're going to skip 12. I don't like 12. 13. I'm going to tell you guys right now, dilations is going to be like way more of the transformations than anything. And that's just to prepare you for high school geometry. Triangle ABC was dilated with the origin and the center to A prime, B prime. Again, we want to create a rule. So we know we're going to go from x, comma y to something. So then we say, this is my old. My old is the small, goes to the large. That means my scale factor is larger or more than 1. So we'll have like a 1 point something to some kind of whole number or a large number. So we're going to go to find a value. So this one, we'll look at B. B's at 3, 2. B is at 3, comma 2. B prime is at 4 halves to 3. 4.5 to 3. Again, if you see, you all know I like whole numbers. So I just want to find the scale factor of my new divided by my old, which is going to be 3 halves or 1.5. I have my scale factor. I can write my rule. My rule is going to be xy becomes dilated to 1.5x, comma 1.5y, or 3 halves x, comma 3 half y. I don't like 14. Oh, let's see, 15. Oh, I don't like 15 and 16. All right, guys, that's the end of them. Thank you. Email me if you have any questions. Hit me on Instagram. My email is just like my Instagram, malbinmadmath@gmail.com.